Hey everyone, welcome to my stream on mathematics. Just an overview. I've got it up here. I'm just starting this. I'm getting better, but I need to be real careful on how I write. So here, notice my writing is quite squiggly. Okay, so just for you, here in New Zealand, we basically have five different streams that we teach in mathematics. My wife kindly made me a cup of coffee. Five different streams. The first one, my writing there is shocking, but under mathematics, the five different streams. The first one is number. Now, what comes under number? Well, all sorts of things. Obviously, the four multiplication, division, addition, subtraction comes under number. And the order of operations, what do you do first? You know, brackets, exponents, that's powers, guys, or indices, exponents. Brackets, exponents, after that comes multiplication and division, whichever comes first in the sequence, and then last of all, addition or subtraction. Again, addition or subtraction, whichever comes first in the written sequence. We'll talk about number as our first lesson a little later when I go from here. But obviously those ones are very important. There are number sets. Number sets can include whole numbers, natural numbers, just the counting numbers, which are 1, 2, 3, 4 without the zero. Whole numbers include zero. Integers are negative and positive whole numbers. And where are negative numbers useful for? Well, for when you're doing above and below sea level, for example. When you're talking about your bank statements, negative would be in the red. So if you've got minus $100 in the bank, it means you owe $100. There are lots of other ways that the negative and positives can be used. There are rational numbers. That means numbers that can be written as fractions with a whole number on the top and a whole number at the bottom. Those would be called rational numbers. Whole numbers are rational numbers. Irrational numbers, numbers that if you were to write them as decimals, would be infinitely long after the decimal point and non-recurring. In other words, not repeating themselves. So square root of 2 is an irrational number. It's not rational. The decimal behind the decimal point, decimal part of the square root of 2 is non-repeating, and it's infinitely long. Shortened down, you can say it's 1.414. Pi is an irrational number. If you know the number E, E is also an irrational number, infinitely long after the decimal point, and non-repeating. Pi, and your calculator will tell you that pi is 3.1415926. I think it'll round it to, but it's actually 2645. If you look at it a bit further, you can check me up on that. I don't always retain these things perfectly. So number can be number sets: rational, irrational, whole, integer, even numbers, odd numbers. There's a heap of number sets. Sequences would possibly come under the topic of number. Fractions, decimals, percentages naturally are involved with that. And let's get our two-dimensional shapes, and we'll add another circle right here and shrink that one down. And I'll write inside of that one as well. There we go. We'll use this one. Yes, we will. And I'll use my writing pad to see if I can get over there. Statistics. I'm going to write it lowercase for this one because it's a long word. Could write stats. How about that? I'm getting better at writing using paint. There we go, statistics. And statistics, of course, would include, for example, probability. And the probability of it being raining today, where I am, here in New Zealand, and in Rotorua, is probably around about 90%. There's your percentages, you see, which can be changed to a decimal, 0.9, or if I wanted that as a fraction, 9/10. You see how number and statistics do link up quite reasonably. So there's two topics, statistics and number. Statistics can become quite complicated. And with higher statistics, you might go and look at things like the normal distribution. For example, if we go to our local Scion station here, where they grow radiata pine or some of the other types of trees we use for timber. They do experiments here to see which ones grow fast and so on. But if you took your typical Pinus radiata and you measured the heights of them after, say, 3 years of growth, they all grown at the same time, and after 3 years, and then you measured the individual heights, they would follow a normal distribution. What do we mean by that? There'd be some very small ones, only a few. There'd be a whole bunch that were average, sort of in the middle, and then it'd taper off to the very tall ones at the other end. They'd follow what's called a normal distribution. If you took the heights of New Zealand males, say 25 and above, or say 25, between 25 and 60, before they start shrinking because of old age. So the heights of New Zealand males from 25 to 60 would follow a normal distribution. You'd have some, it wouldn't be exactly normal because today's youth tend to be a little taller than those that were born 40, 50 years ago. Diet has a lot to do with it. So you'd actually have quite a few shortish people, perhaps because of diet. But you'd get more along the taller side. Youth these days do tend to be somewhat taller than they have been in the past, but nonetheless, it'd follow more or less a normal distribution. Whereas, for example, if you added females in there, it wouldn't follow the normal distribution. It would have two high points because you ladies tend to be a little shorter than us men. Just the way the Lord organized it, I guess. I don't know why that is the case, but that's the way things have worked out. And that has its advantages and it has its disadvantages. And vive la différence, as the French would say. I'm really thankful that there's a difference between males and females. I love my wife dearly, and I'm glad she's a female, and she's very different to me. I tell you, she is very different to me. And she compliments me, not compliments, but compliments for the many lacks that I have, which, yeah. And the things that she lacks, I also, whoops, that shouldn't be filled in. I don't want that. Let's do this one, and we'll see if we can get a circle here as well. There we go. We'll pull that whole thing down a little. There we are. That's fine. This can go up. This can come down. Okay, what have we got over here? I think we might put in measurement there. Okay, so statistics is far more than what I just mentioned, by the way. Yeah, we got the probability distributions, Poisson, binomial, normal. When you get into higher learning, you learn about that sort of thing. But at junior level, it's more the probability side, long run probabilities, where you see how many times by flipping a thumbtack, how many times it lands on its back and how many times it lands on its side, that kind of thing. You can do these trials to find probabilities. It's a big part of statistics for the juniors. Okay, let's move on to this one here, and I will put measurement right in there. Also a fairly long word, so I don't want to there we are, we've put it in nicely. Measurement. Oh, I'm going smaller and smaller, large number, smaller. Okay, measurement, what does that involve? Well, areas, perimeters, volume. It's very closely linked to this one down here, which is going to be geometry. So shapes, closed shapes, three-dimensional shapes. Measurement can also include the size of angles, but geometry comes under the size of angles as well. And if we have algebra over here and geometry, you'll find trigonometry links to them both. We tend to put trigonometry with geometry rather than algebra, but nonetheless there's a huge amount of algebra inside of trigonometry. So with trig, you are looking at year 10 in New Zealand. We do some trigonometry in year 10. But in year 9, with the extension classes, we would tend to have some trig. And I really enjoy trigonometry. It's a great little subject. But measurement will include units. So for perimeter, distance around something, you might be using meters or centimeters or even kilometers. Distance around the Earth, for example, you're looking at about 40,000 kilometers, which, by the way, was worked out fairly accurately by the Greeks, maybe 300 years before Christ, something like that. I don't know the exact time, but it would have been in that area. As was, by the way, the radius of the Earth from its center to the outside. Interesting fact for the Earth is because it spins on its axis around the equator, it tends to be fatter around the equator than if we measure it around the poles. So if this shape that we see right here, this oval, the equator would be across here and North and South Pole would be there because it's spinning around and it tends to spread in the direction of spin simply because of centripetal force. Whichever one. Okay, so we've got measurement here. Units is important. So for perimeter, it's simply the distance. Meters, kilometers, centimeters, millimeters, nanometers if you're talking about the tiniest things like viruses or bacteria. All in science. Love science too. It's brilliant. But measurement is an important part of that. So, measurement. If you talk about area, you're looking about square meters. How many square meters in this room? Well, if this room is, say, 4 meters wide and, 4 meters long and 3 meters wide, which must be fairly close to what it is. How many square meters could you lay out? Well, 4 times 3 is 12. 12 square meters would cover this room. Why are square meters important? Well, if you're painting the walls of your house, you'd need to know how many square meters, after you take windows away, how many square meters are needed to be painted, for example. And if you're going to do 2 coats of paint, you'd need to double that. We've just finished painting my son-in-law and my daughter's house. They've got 3 kids. My daughter calls the shots, as my wife calls the shots in this house, as far as the making the place look like a home. And both of them do an amazing job. They do such a great job making the place look really smart. You guys that are listening to this, if you intend to get married, let your wife do the decorating. I mean, if that's her forte. If it's yours, work together. But for me, being a little colorblind and not really minding how the place is set out, it's a good idea to let the wife sort that side of things out, and do your part in the home. What's more, because the ladies do. Especially if they're working, you've got to do your part in the home as well. And if you're young, get used to doing your part in the home right now with your parents. Do your chores. It's just good practice, good health, and it means that once you get into a relationship and you decide to have kids, you're not known as the lazy one. around the place. Hey, I'm going to, this is all just extra for you guys. I'm going to do another circle over here. Let's see, there we go. We'll pull that whole lot across. There we have it. Yep, we'll drop this one. Whoopsie. Okay, that's good. Oh, that wasn't supposed to stay like that, but that's all right. I'll leave it like that. I'm still learning how to do this well. And I'm going to use the brush, and here goes geometry. That's going to be slightly bigger because it's not as big a word as measurement. Don't you love paint? All right, so we've done measurement. Units. Oh, by the way, the units for measurement for three-dimensional shapes, like a sphere or a cube, the units are cubic. That's to the power of 3. Why? For example, when you're doing a cube, length times width times height, all of them being equal if it's a cube. So meters times meters times meters, m times m times m. When you get to algebra, you realize that's m to the power of 3. That's why we use cubic meters as m to the power of 3. So in this room, the height of this room is around 3 meters. The length is about 4, and the width is also about 3 meters. Okay, so 4 times 3, pardon me, 4 times 3 is 12, times another 3 is 36. Meters times meters times meters, 36 meters, 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 36 meters to the power of 3, 36 meters cubed. Sorry, it looks like I'm doing something else with those fingers, unintentionally, guys. Anyway, let's move over to the two-dimensional shapes there, and we're going to do, so yeah, that was measurement. Geometry. Geometry is naming shapes. It's finding directions. So you might go, we're heading north, which would be straight up the page, or east, which is to the right, or south, down, and west is to the left. And if you're doing bearings, 0 is north, 90 is east, 180 is south, 270 is west, all the way around to 360 or back to north. So 360 degrees in a full rotation. So we say angles at a point, the point being in the center, they would have to add up to total of 360 degrees. So if you put a cross in the middle, you get 90 and 90 and 90 and 90. So 4 times the 90 gives you a full 360 at the point in the middle, you see. Angles at a point, 360 degrees. Or angles when you complete a full circle when you're going around a building, whatever it is, you've completed 360 degrees. Okay, so geometry, finding the angles inside of shapes. For example, the angles in a triangle add up to 180 degrees. The angles in a rectangle or any quadrilateral, notice that word quad means 4. Angles in a quadrilateral, any strangely shaped 4-sided figure, is 360. And every time you add another side to it, like a 5-sided, a pentagon, or every time you add another side, it adds another 180 degrees. And we can show you that by splitting the shapes up into their various triangles. Every time you add a side, you're going to get an extra triangle that you can fit into that shape if you make that the triangle start at one point, one vertex, one corner of the shape. Okay, so geometry, naming shapes, angles within shapes. If you have a quadrilateral inside of a circle, knowing that the opposite sides of the quadrilateral, the opposite angles in a quadrilateral, in a cyclic quadrilateral, where all corners touch the circle somewhere, opposite sides add up to 180 degrees. It's various things like that. That a tangent to a circle meets the radius of the circle at 90 degrees. There's numbers of things like that. Tangents from the same point outside of the circle reaching the circle, those tangents are the same length. Yeah, there's a whole lot of neat things that fit into geometry. Notice angles is a big one, and with trigonometry, the angles is also part of trig, finding the angles within triangles. When you're starting off at the junior level, it'll be in right angle triangles. Later on, it'll be in scalene triangles or non-right angle triangles. All right, enough. We're going to look at this one again, and we're going to create a circle around about here. And I'm going to shorten, not that way. I'm going to pull that down. Can I do that? Yeah, but I also want to pull this one down and pull this one up a bit. Well, I still can. I couldn't do it with the geometry for some reason. Okay, brushes. Our final one, of course, is algebra. And I really love algebra. And it's one of the shortest ones. Words. But very important. Very important if you're going to become an architect or an engineer, you need to know algebra. And it's not hard, to be honest. And if I was to start saying, introducing letters into algebra, which throws some students terribly, I would start by using an empty box and saying, okay, this something that goes into this box plus 3 is equal to 5. An empty box plus 3 equals 5. What number would have to go into the empty box? And you would say something plus 3 is 5. That would have to be a 2, and you'd be dead right. But then I would write underneath that x plus 3 equals 5. And rather than freak out, you would instantly know what I meant. Something plus 3 equals 5. And you'd say, oh, well, that means x must equal 2. Notice I've introduced a letter into algebra, and it hadn't blown your mind, because you've done that at primary school, you see. And it's very easy to work things out in that way. Now, algebra, it does use the letters we call variables. Or sometimes the letter can be this, and sometimes the letter can be that number. If I said 3 times p is 15, you'd say 3 times something is 15. I don't know my times tables. I hope you wouldn't say that. I hoped you'd be able to say, well, I know 3 times 5 is 15, so p would have to be equal to 5. And you've just solved another algebraic equation. Not all of algebra is equations, but you get the picture. And that algebra feeds very nicely into trigonometry, and geometry feeds into trigonometry, and measurement feeds into trigonometry. But you can see how these all tie in very nicely. Those are the 5 things, guys. These are the 5 topics that you will need to cover in junior high school, at least here in New Zealand. Number, measurement, geometry, algebra, statistics. Little bits of those at least, just to get a handle on how things are going. So that I will upload this to YouTube, and I hope that's been a blessing to you, especially to you people who are considering tuition for your students. I'll leave a link to our tuition site, which is backtobasicseducation.org. You can go on that site and you can request that we become your tutors. We not only do mathematics, we can do science, we can do, I have an English teacher that can work with you. I do study skills myself, but I'll write down back to basics. You can all one word. I'm going to have to rub that out. Sorry, guys. Undo. There we go. There we are. Just put the whole lot in, single word, backtobasics.org, and you have our site ready to go. And you can enroll, put in an enrollment form, and you can also contact my daughter who's organising that, and she will put you in touch with one of our teachers. But for this one, I'm happy to take you for that. And if there's more than one, then the price comes down. So we do this on Zoom, or even on I can do it on Paint, but basically on Zoom is most likely where we'll go with that. So thank you for joining us this morning. Just as I say, get that one down, and you can contact us that way. There we go. All right. God bless you all.